So this question says the volume of the box shown below is 72 cm cubed. So this is a box, this is a drawing that they have here. What shape is this box? So do you remember your 3D shapes? Your solids? You could remember what types of solids you would have looked at before? What shape is a dice? Or a die? What shape is a die? You ever play Ludo or Monopoly or any game that have like snakes and ladders and you ever play those games?
Yeah.
And you just have to roll a 6 to come out. So like for snakes and ladders, for example, you just have to roll a 6 first before you could start to play.
Yeah.
And you just roll a die. So how many faces that shape has? If it have a number on every single side. And you had to roll up to 6, right? That's the highest that you could roll. How many faces does that shape have? So that shape, right? That 6-faced shape is called a cube because it is a solid that is comprised only of squares. It has 6 identical faces. And this one, if you look at it carefully, what shapes do you see in this 3-dimensional shape? What shape is this? What shape is this? What shape is this? What are these faces called? So what do you call a 4-sided figure, right? That has a pair of sides that's longer than the other pair of sides. So if we look at this particular face, notice that this side is the same length as this side, and then this side is shorter than this one, but it's the same length as this side, right? And that's noticed right through for the entire shape for all the faces. What shape that has 4 sides where 2 sides are the same length and 2 of the other 2 sides are shorter in length but the same as each other? What do you call that shape? What do you call this shape? Start with a R. We dealt with it earlier when we had the shaded triangle. What shape is this? What shape do we have here? You could remember the name of the shape from earlier, where we had the shaded triangle inside?
No.
Okay. A 4-sided figure. So we met a square earlier. What do you call the 4-sided figure where these have 2 long sides and 2 short sides? Start with a R.
Rectangle?
A.
Rectangle?
Very good. A rectangle, right? So this is a rectangle. So a solid that is comprised mainly of rectangular faces, which is this one, is called a cuboid. Have you ever heard of a cuboid before?
Yeah.
Yeah? Good. So what we need to do is calculate the length of the box, right? So we need to know first of all what shape it is, because we can't just go randomly and take numbers and just try to do something with it, right? So if they tell us that the length of the box is missing, but they tell us the volume of the box and we know what shape the box is, we should be able to calculate this length. Alright? So let's see. How do we calculate the volume of a cuboid? Do you remember what is the formula for the volume of a cuboid? So this long side that's marked off as L, we'll call it the length, right? This is the length of the cuboid. Right? This 4 centimeter distance here, we will call this the width of the cuboid. So this distance here is the width of the cuboid. And this distance here is called the height of the cuboid. So solids usually have 3 dimensions, right? And they are the 3 dimensions in particular for the cuboid that we need if we want to calculate the volume. Alright? So the volume formula is the length by the width by the height. Alright? So this is a product, meaning that we're going to multiply the value of the length by the width by the height. Now the thing that we just said is the length is unknown, but we do know the volume. Alright? We do know the volume. So we know the volume is 72 centimeters cubed. What is the length? We don't know, but we want to find it. Can you tell me what is the width of the cuboid? They did tell us what is the width of the cuboid in this diagram. So if you look carefully, the width is this distance over here, right? I heard you say something. I think you're on the right path. I think you know what you want to do. So what is the height of the cuboid? The cuboid is 3 centimeters high.
4.
Alright. What's 4 by 3? Will you tell me just now? 4 by 3 is? Four by 3.
12.
12.
12.
Right. So the volume is the length of the cuboid multiplied by 12. If we want to get the length, right? We're trying to find the number that we multiply 12 by to get the 72. So what do you think we should do if we want to get the length? What do you think we should do to get the length? We have the volume. We don't know the length, but we know what we multiply the length by to get the volume, right? So this means you'll have to take the length, sorry, not the length. To get the length, you'll take the volume and you'll divide the volume by 12. Alright, so we'll divide 72 by 12. How many times can 12 go into 72 without leaving a remainder? So I want you to check your timetables and see where you find 72 in which timetable you're going to look in. What number we dividing
8.
by? Okay. So you're going to look there for 72?
9. 9.
Okay, so you see in 72 in places then. So you see in 72 in 8 times tables, you see it in 9 times tables. But what number are we dividing by? Are we dividing by 8 or 9? What's the number we dividing by?
8.
In this statement. What am I dividing 72 by? What's this number? What's this number? Over here is 12. So if we divide them by 12, you should actually look not in your 8 times tables or your 9 times tables, but your 12 times tables, right? So I want you to go to your 12 times tables. I want you to see what number you're multiplying 12 by to get 72. Twelve by what will give us 72? You found it as yet? So 12 will divide 72 exactly 6 times, right? So the length of this box is 6 centimeters. So our answer is 6. Alright, the last part is a nice easy part because we actually calculated it earlier when we were doing the volume. Calculate the area of the shaded face. So the shaded face on this diagram is this side here where they told us the height and they told us the width. So the area of that shaded face would just be 4 by 3, right? 4 by 3 because it's a rectangle, and 4 by 3 is 12. So our answer is 12 centimeters squared, right? So this is what the complete solution for this question would be like, right? So we get the answer, sorry, for the length as 6 centimeters. And then to calculate the area of the shaded face, you just had to multiply the height and the width and you would get 12, right? So this is how you work this one out.